Cool. Hey, how you doing, folks? I'm trying to do an update on my Samantha fixture project that I've been working on the past few years. Kind of at a good point, we're late 2025. I've got a bit of experience with it, and I've been improving lots of little details about the fixture over time. So this is kind of like a reiteration of past work and some catch up so that everything's to this point is kind of in one video, and it's kind of, this is where we are, okay? So what I decided I'd do is I'd go through setting up the fixture on the table. And we're starting with a bare table, and we go over some points, okay? Right now, what you see here is a setup for flattening this surface. I've added some calibration screws to the Rhino cart top because while we can maybe level it on average with the leveling feet, what we also need with regard to this is a flat surface. And so I've got little set screws in there that can help me with that adjustment, and I read it out over here. Now, people that know what they're doing know that this isn't a real straight edge. It's, largely a carpenter's level. But it actually is fairly parallel for the uses I've got here, so it's working. My problem is a real straight edge of the length I want, about 60 inches, is in the $1,600 range, and I'm not going to be spending that just yet. Hopefully if I can find a deal on a used one. But anyway, this is the setup, and so basically we start with a datum in the corner and we go to various points where I have adjustments around the table, and I make everything level to that. Then effectively we have flatness. Now, it's not flatness like we would produce with an auto collimator, but it is flat enough for fabrication work and certainly for bicycle work. This is definitely a good thing to do. And if you have a Rhino cart without calibration screws cut in it, you should do that for sure, because they can be improved significantly within I think a thousandth or 2/1000ths of an inch of flatness. Okay, so I have this set up here, and I'm going to remove it for the duration because we're going to assume I've gone through and flattened it out. It takes a bit of time. Okay, so I'm going to put that there, and I'm going to put that there, and I'll put these there. Okay, so we have a flat table. What do we start with? Well, like in most environments with bicycles, we start with the bottom bracket tower, or as I like to call it, the crank axis tower. Now, this one has a bleed hole for the purge. I like to point that to me. There it is right there. I like to point that to me, and here we go. And we tighten it from the bottom, and this is, I believe, the only screw that we're doing from the bottom, but it provides an incredible amount of rigidity here. I use this for alignment purposes as well, for the scale that I'm working at. And we have this nice shaft and spacers built right on there. So we're spacing it up, and I have nice shim stack of spacers that are set up for the bike. And 1 second, I forgot something. When we are setting up, there's got to be a height here that we reference to outside of the shell for, but we're going to do the fine tuning once everything's on here. Right now we're installing it. So I have this is cylindrical there, and we come down, put that there. Now, next step, I've got this cool system here, the cones. This is still parts left over from Cyberdyne, where I've got a cone in that step there. So this goes on, that reducer there, and it's very loose. And this goes on, and that brings it on center. And that's so that if there's any weld distortion clamping it, slight movement here will loosen up it entirely. which is pretty cool. And then of course we have our screw there. Okay, once we have the tower in place, now we start with the actual setup, and these numbers will be coming from my setup sheet. And the first thing we do is place pins. And I've got calculation here for the measurement pinhole for the head tube is going to be 6 on the Y, 1, 2, 3, 4, 5, 6, and then 9 across, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And we put that in there. Okay. Now, to be expedient, I've left these magnetic threaded holes on the back side because they kind of stay in place. That makes everything very easy for just screwing down to the table. And we can use much lower priced shoulder screws or screws like that than the fancy the ball locks here. We don't want to use these, not because they're not awesome, they are, but the thing is that they're very expensive. And by using other types of fasteners, we can lower the price and make it much more flexible. Now I do the seat tube pin, and that is Y is 7, 1, 2, 3, 4, 5, 6, 7, and then minus 5, 1, 2, 3, 4, 5, right there. It's almost like we've been through this before recently with the Corsair, unless I've changed something accidentally. So these are nice and easy. Now we do the rear center. Rear center table Y is 1, and then minus 5 again. 1, 2, 3, 4, 5. All right. So this makes it easier, huh? Once these are in here, that's basically our guide for everything else. So I'm going to put in the head tube. And we set that up here. Now, of course I forgot something. Hold on. I'm going to do everything onto the table now before I bolt it. Oops. All right. Let's see. Got 2 or 3 parallels. One's for the rear, 2 for the front. Okay. So I've just dropped these in, and I'm going to grab my screws. And these are from Build Pro. They're very similar to a shoulder screw, but they've got that countersink on them. And we take advantage of that. They're fairly inexpensive, so we like them. But we're going to take a look at our setup on the table. And for my measurement, let's see, my pin gap distance on the head is 2.243. 2.243 is about in there. That means I'm in the right zone. Actually, I'm going to do this. Similar to that. And it'll slide back like that. And of course, whoops, that's not supposed to happen. So my pins would go right in here, and then I slide up. We do have to remove this one just because of the positioning. All right, and then we throw these guys in there. And we screw it in. Okay, so you can see that that moves really nice. Now these guys aren't screwed in because they're missing threads on the other side, but you get the point. I just screw those in. Let me put this back now. And clamp everything in place, but then loosen it just so that we can set this at 2.2. Oops, 2.243. All right. Yep, that's what it was. And we clamp it down. Now on the other side, we do our seat tube, and the seat tube is 1.243. Oh, I gotta screw it in. There we go. And we got these in there. My nuts on the other side are missing here, so same thing as the front. Take that with a grain of salt. Trying to make a video here, you know. So these went in, and you can pretend I did those. Okay, so now I'm going to set this at 1.243. And I loosen this up. 1.243. In a perfect world, I'd be taking much more time and care. I'm trying to do a demo. Okay, and then down on this end, we're going to do we've got this pin here. Now, this is a much more interesting setup than the others because while these are, in a way, these cylindrically type coordinated, a transposition of sorts. We're trying to take a rectilinear type approach back here, or XY, but how do we save the precision of the table for doing this? Well, I'm gonna show you, because this is kind of neat. And of course, these guys aren't right. I made a modification to these rails. That's why things aren't in the right place, to make it nice and quick and easy to set up. I should have gone through this earlier. Okay, so to do this Y dimension here in the back, we're actually taking a hypotenuse measurement, which is kind of interesting. That was some fun math. So if I go to the Y distance here, it's going to be 2.707. So I move it down to 2.707. It's pretty good right there. So isn't that interesting that that set the Y, because we knew the location of this and we're on the next rail next to it, that we can use that hypotenuse to actually set the vertical. Okay, now we have the X. Now this is just here to make that dimension easier, and I'm going to get a calculator, hold on. Okay, so now to use this, we're going to take 3.061 and subtract 2.5 inches, because that's the length of one of these blocks. And I get 561. So I come back here, and I just put that up there. And Again, I'm rushing right now. It's 0.561. Now, of course, I would be taking much more care with that measurement. In fact, if you've seen my bike setup stuff, I actually use gauge blocks in there. And then I just push it right up against it, and then it's dead nuts. So this rear is set, and we can place our axle in place, just so you see it. Boom. Got an axle and a bottom bracket here. Now, we've adjusted the position of this pivot point here, but we haven't adjusted the angles of these tubes. So now we're going to set the angle, and I have that's what's called a cosine spacer. So say for the rear it's 3.394. I'm taking and I'm measuring back here this distance. Here, we'll move these out of the way. This distance, so 3.394. Oops. There we go. And cinch that down. So now everything is set up for this, the seat tube. It's offset and everything. We go up to the front. One of the recent modifications was to make sure I could do the longest, what is it, an 18 hole, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. An 18-inch cosine bar sets this angle, which is fairly precise if you know about those things. So I'm going to set that angle by measuring this, and I'll be measuring it at head tube cosine 5.263. So I loosen this up and I measure 5.263. Boom. There we go. Let's say I spent the time. So now the head tube's all set up on the axis, but we haven't set the bottom of the head tube. That's where these guys come in. We're going to go over here, and this is just to subtract 5 inches off the top. You don't need those, but they make life easier. So this dimension is going to be 10.051, and we subtract 5 inches because of those blocks. 5.051 is what we're looking here. 5.0. Here, let's fix that. Here we go. See how we can set this to within 1/1000th of an inch? Whoop. Oh, there we go. That's why. That's why. 5.051. There we go. We're going to call that 5.51. Okay. Whoops. That's not good, but we know what we're doing here. Okay. So now we went from, since this is placed, I have this additional clamp here that keeps the bottom of this rail from floating around or anything like that. And we put that in there. And this is a pretty cool engineering job for that. Boom. Now this stuff is rock solid. Now we start from a bare table, right? Now we have the next stage in this whole process here. I'll actually, this is held on a V block there. And boom. Okay, we're going to do calibration now. So calibration is really cool and something that took a while to develop. This is an ER50, call it. Huge. Okay, let's start with the bottom bracket tower. Now, one of the difficulties with working with a plate the way we are and laying horizontal, which is very different from what others do, is we need to make sure that both of these axes are perpendicular to the table. Now, you saw at the beginning that I had made sure this table was not only level but flat, or flat but level. So what we can count on is that if we're a certain distance over here on the table and level, it's going to be true all the way down at the other end of the table. So check this out. We have another ER50 collet in here for 1 inch, and that goes onto there, and I tighten it, and I have these cool tools that I'll use just to, well, here we go. There. And I'm going to cinch this on there. Okay. So now the question is, are we level? See, I've created with this collet holder a perpendicular surface. And if I go here now, I should, on my bubble level, be true in each axis. So I can see here that this side needs to go slightly higher. And you can see I'm just turning these calibration screws at the base. And I do it for here. And I get it really nice. Oh, baby. It's pretty good. Now, I'm just going to double check the tightness of this. Oops, I used the short screw thing. All right. So how's that? I just calibrated the bottom bracket axis to the whole frame. It's true now. Cool. Now I have to take this off because I currently don't have 2 of these holders. Oops, wrong way. Here we go. Sorry. There we go. All right, so now we're going to take out that collet. There we go, nice one. These are the, what is it, Lindexes. They're very precise. And I got ER50 because there's so much surface area working there that even if I wasn't tight, it wouldn't be that big of a deal. So we're going to take out our dummy axle. One of the mods that's coming up is I'm going to redo my own dummy axle system because I'm a bit tired of the old anvil style. There's a much better way. This cutout section I don't think makes fixturing better. I think it makes it much worse. So I'm going to do a different system. I think it's similar to Sputnik or Alex Mead, but with my own twist on it. Anyway, I have this ground piece of 1/2 inch stock. Right? Very cool. It's all straight. Now I grab my calibration plate again and I throw that on there and I tighten it down. All right. And then I grab my machinist level. Now I have some experience with this. And it's a much more fussy adjustment. And we need this long Allen wrench. And I have screws at the base of this column that I can kind of tweak. And sometimes you gotta loosen the tension screw a little bit to get it going. Boom, we're good. And it stays nice. All right, so isn't that cool? Basically, we just calibrated both of these so that we can count on them. Oops, where was that? There it is. So that we can count on them. That wasn't enough to throw it out. Okay. And we move this stuff off. Oh, there's one last thing that we got to do, but let's clear out most of this stuff. Okay, so now we have the one last thing is the crank shell height. And here, we're going to switch to metric because this is a metric rule. I need it 197 from the table surface. And I look across there, and son of a gun if it isn't dead right. I'm looking at this edge here, the outer edge of the width of that central symmetric shell. And we can put this back. Get that going. I'm going to talk about one more thing. So, what you see here is a bike, jig, set, ready to go. Now, I created it from a flat welding surface that you'd have in your shop. You don't need a special fixture with these plates that can be stored on a shelf. I wanted to show off these. Let me get a wrench here. These are UDH dummy axles, and here's a 7mm UDH spacer. But if you notice, each of these holders goes into a setup like that, so that I'm not holding on a tiny little shim. I'm holding by a depth of that insert there, which is approximately 8mm on either side. So we end up with something like that for that UDH interface. That's a really cool system. There we go. This is the Samantha fixture as we are right now. Everything drops in. It would be smoother if I was taking my time and if we were just kind of chilling in the shop. But I just threw that thing on there and I set everything. It's set and ready to go for a frame. And we even started knowing that the plate had been leveled and calibrated. That's why I talk so much about this fixture. It's amazing what's happening here. There you go. Thank you very much. 2025. Okay, there's one more thing I didn't mention earlier is that I have this dummy wheel, and it's been mounted to the dummy axle, and we can mount that into the fixture. Oops. There we go. Mount that into the fixture. So now we can get our chainstay and seat stay spacing dead nuts at the top where the tire's interacting, and we can calibrate this by measuring off the surface of the table as well. And we can do the same while we're producing the stays and everything like that. But this is a nice auxiliary fixture that can go in any way you want, that builds off of the rear axle itself for conformation. A very valuable tool when you're kind of fighting things sometimes. And I just wanted to make sure you saw that.